presentation of George. He will be talk about introducing VR on your Java world.
Alright. Hi everybody. First of all, can you hear me like this, or do I need to stand like this? Is it okay? Can you all hear me? All the way to the back? Alright. How are you all doing today? Everything's fine? Good, good, thanks. Alright, so my name is George. I'm from Greece. A few words about me. I'm currently working remotely for a US-based company, and I'm an organizer of the digital meetup there back in Greece. So today I'm here to talk about a new way of implementing virtual reality in our own existing apps.
Microphone.
Should I talk in the mic? All right. So I'm gonna be like this in the whole presentation. Today I'm gonna show you a new way of implementing virtual reality in our own Android Studio apps. So let's begin. Let's begin by defining what is virtual reality. By show of hands, how many of you have ever developed anything for virtual reality? 1, 2, 3, 4, 5. Good, good. All right. How many of you have ever experienced virtual reality? That's what I like to hear. Good. And anybody who doesn't know what virtual reality is? Great. Well, if we open a Wikipedia page, we're gonna read that virtual reality is the term to describe a three-dimensional computer-generated environment which can be explored and interacted with by a person. Okay, that may sound correct, but if you ask me, this is kind of boring. If you ask me what virtual reality is in 3 simple words, I'd say that it's cool, it's innovative, and most of all, it's fun. It's fun to develop for virtual reality, and it's even funner to actually use in virtual reality. So, we've established that virtual reality is cool, and let's see what are the actual requirements in order to create a virtual reality app. First of all, our app needs to detect head tracking. So we're going to have to find a way in order to see where the actual user is looking and render the picture accordingly in order for the user to see something different. Next, we're going to need stereoscopic vision. We need stereoscopic vision in order to give the user the illusion of depth, and thus we enhance the user experience. And of course, finally, we need to compile all of this into special software, some virtual reality apps, and use them with a headset, Google Cardboard, any other headset you want, you name it. Now, all of this is cool. How do we develop all of this? Thank God there's Google, and they have SDKs for pretty much any well-known platform we could use. We have SDKs for native Android, we have SDKs for native iOS, and for those of you who actually don't want to go all the way native, they have SDKs for Unity 3D and Unreal Engine, so we can develop on pretty much anything. On my presentation, there are links for the documentation of all of this, so later on you can go and explore this. Today, though, we're going to talk about native Android SDKs, so let's talk about what the Google VR SDK for Android does. What it does is that it enables OpenGL developers to pretty much create their own 3D world, and then they use Google SDK's VR camera, and this camera detects head tracking and user actions. This is good, this is fine, but for me personally, it's not enough. I'm not a big fan of OpenGL, so I want to find a new and easier way, if you want to say so, to actually develop something like this. So I found this library. This library is Rajawali 3D. It's actually an open source framework. You can find it on GitHub. And what it does is that it helps us create 3D environments straight on Android, and we can use it for apps, wallpapers, live 3D wallpapers. Yeah, I already said. Okay, so it's faster, it's easier, and all of this is because we actually don't need to go all the way down to OpenGL. We can have ready-made objects and Java classes like, spheres, cubes, and all of this. So we can add textures really easy. We'll see how in a moment. And all of this makes our job really easier. And of course, they have a VR module for this. That's why I'm here. As I told you, they already use Google's latest Android VR SDK. So they work on Google's SDK, and they take care of all of the OpenGL development. Now, let's start by taking a step-by-step tutorial in order to see how to make a VR application. What we're going to build is a simple panoramic photo viewer. The first step would be to actually download and build this framework. So you can either do it from the Razawal GitHub repository, but if you do that, you're going to have to download and then build the actual modules for your Android Studio right on your client, right on your computer. If you're too lazy to do that, you could download some pre-built frameworks. I have one on a repository on my GitHub account. There are some other frameworks on other GitHub accounts or on the internet. You'll find them. Right after that, you just create an empty Android Studio project, and all you have to do is to import the two basic modules you're going to need. The first is Razawali module, and then you have the Razawali Cardboard module. It's no big deal, right-click, new module, import, done. Next, of course, we're going to have to add the compile project statement on build.gradle app. So we actually compile those modules, otherwise we're going to have nothing, I guess. And then we add the uses permission and the uses feature tags on our manifest. For virtual reality, we're going to need permissions for NFC, read and write external storage, and vibrate. That comes straight from Google, not me. And our phones or tablets are going to need to have the feature of OpenGL version 2. We don't need to go all the way to version 3. Version 2 is fine. Yeah, last but not least, we're going to have to go all the way to our VR activity and define the screen orientation into landscape. We don't need to, go all the way from portrait to landscape. It's not good. It's not something good. So we set the screen orientation straight on landscape from the manifest. Next, this is probably the hardest step. We're going to have to create our own custom renderer. Do any of you know what renderers are and pretty much what do they do? 1, 2. Good. All right. I'm probably going to have to talk a bit more about this. So, on typical Android Studio projects, we have our activities, and our activities are a Java file for the logic of the activity and an XML file for the view. There are some cases that a single XML file is not enough in order to define a single view. So if we don't want to use single UI elements, for example, like in our case, so when we want to do something like this, we actually create a new Java file, a new class that's actually called a renderer, and this Java class contains the view that we actually want to render. So that's pretty much what we want to do right now. In order to use the Razawali framework, we're going to have to create a new class. We're going to extend it on a specific Razawali class, and after that, all we have to do is to override the initialize method. It's a method that runs only once when the renderer is created. And over there, first, of course, we position and rotate the camera. And after that, we're pretty much free to do whatever we want. We can create our own 3D board, but in our case, all we're gonna do is to create a panorama sphere and position it right in the same spot as the camera. So whenever the user looks, it actually looks inside of the sphere. And in this sphere, we're gonna add a texture of our panoramic photo, and we're done. This is our panorama viewer. Once we do this, last step is to actually render this view from our activity. So we just inflate our custom renderer by creating the object of our class and sending the content view of our custom renderer into our activity. Now, in order to recognize user actions, we're going to have to do either one or both of two things. First thing is to implement on-click listener on our custom view. This is for Cardboard's version 2 and later. For Cardboard version 1, which has the magnet thingy, we have to override the onCardboard trigger method, and that pretty much takes care of all the magnet work. So if we implement those two things, we can have full user interaction either with the magnet or the screen touches. Now, let's do all of this in a live demo, just so I show you how easy and quick it is to actually create an app like that. There we are. So I'm actually not going to create it. I'm not going to create everything from the beginning, but I already have a project ready, and I'm going to show you exactly what I did. So first step is to actually download and import the two modules. So we have the Rajawali module and Rajawali Cardboard module. We don't care what's inside this module, we just leave them there. So once we do this, it's actually good to, have one or two panoramic pictures. That's the two pictures I'm going to use, just so you see. It's something like that. It's a simple panoramic picture of my city. And after we do this, we go to the build.gradle file on our module app. As I told you, we have to add the compile project statements in order to compile those two modules. And then we go to our manifest. The manifest, we have the user's permission for NFC, read and write external storage, and vibrate. And the user's feature for OpenGL version 2. And then I'm having only one activity tag because our main activity, the activity that starts, is going to be our virtual activity, or our VR activity, but you can add as many as you want. But on your VR tag, you have to add the screen orientation into landscape. Now, let's go to the hard part, the renderer. You're going to see that it's not that hard. Well, okay, so we begin by a simple class. I named it whatever, my renderer, and as I told you, it needs to extend this specific Rajawali class, Rajawali Cardboard renderer. Once we do this, we just need to create a simple constructor, give it a context, and call it super. It's easy. Then I'm creating a sphere object. You see, we don't need to have any OpenGL knowledge or development. We just declare a sphere object. Anybody who has actually worked on OpenGL knows what a relief this is. After that, we actually override the init scene. We set up the default camera and the panorama scene. So we get the current camera, we position it wherever we want. I put it on 0. And we set the rotation to 0, 0, 90. I put 90 because by default the VR camera looks down on the 3D world when the user looks forward. So we have to position it to look by default forward, so the head movement of the user and the head movement of the 3D camera be exactly the same. Me personally, I like to set the field of view on my own custom radius to 75. You can leave it by default, you can open it up, close it down. This is all yours. So, as I told you, after we do that, you are pretty much free to create your own 3D world, but as for me and for this workshop, all we do is to create a simple panoramic viewer, so I'm creating a simple sphere. How do I do that? Creating a material, initializing it, I set the color to 0, so it doesn't have any other color, it just has the texture. And after that, I'm adding a texture of the drawable that I just showed you before. once I create the actual material, I initialize the sphere. Those numbers are for the radius of the sphere, the segment's width and height. I came out with these numbers just by experimenting. Once again, you're free to experiment yourselves, see what suits your case better. And after that, I set the scale of the sphere to -1, only on the x-axis. That's because the camera is actually looking at the sphere from the inside of it. So if I didn't have this line, everything is going to be like a mirror, because the left is going to be on the right. So by setting the scale x to -1, it flips the image and we're looking at the right result. After we do this, we set the material of our sphere to the material that we just created, and our sphere is done. We add it as a child of our current scene, and we're good. And as you see, all of this has to be in a try-catch, just to make sure that the texture actually exists. But actually, I don't think that I've ever been here. Yep. Now, this is not mandatory, but in order to actually run any action when the user clicks the magnetic button or the actual button of the cardboard, you need to create a public method inside your renderer and then call it from your activity, because that's the only way to actually make any changes in your renderer from activity. You create a public method. I'm calling it change panel. That's going to run every time our user interacts with the cardboard. It's going to vibrate our device for 200 milliseconds, and then I'm creating a new material from an integer drawable, and I'm putting it on the sphere. Now, this method is going to run from our main activity, which is our last step as well. So, our main activity as well needs to extend cardboard activity, not action bar activity, not any of this. It's going to be extending cardboard activity. And we need to declare the Rajawali cardboard renderer object. And other than that, in our onCreate method, all we do is that we actually initialize our view. So Rajawali cardboard view equals new Rajawali cardboard view. We set the content view of our screen into this view, and we set the cardboard view as well. That's why we need to extend cardboard activity. After that, we initialize the cardboard renderer object that we created before. So we initialize it in our own custom renderer, and we set the renderer of this view on our own custom renderer. Of course, we need to set the surface renderer as well. That's like typical and default for everything. Now, we can see that we have a few easy methods that we can use. One of them is the set VR mode enabled. So if I comment it out or if I leave it to true, what's going to happen is that when the VR app launches, I'm going to have the typical stereoscopic images, so the two images side by side working as we know, just so we can see it in a cardboard headset. If I put it in false, it's going to have one big image. It's still going to detect head tracking, but it is in a sense so we can use it outside of cardboard. This is mostly used, in something like settings or set preferences, so we determine if we actually want to see our panorama picture inside our cardboard or not. Now, as I told you, we need to set the on-click listener of our view, and on-click, that's like the action we just detected. We run the change panel method that we made before in our renderer. So, we run the change panel method and we give it, when we pass it the second drawable we want to render. And we override the onCardboard trigger for cardboard's version 1 with a magnet. And in my case, I do the same thing. Probably I should create like a standalone method just for this and run it from both sides, but it's just one line of code anyway. So with only this, you can create so simple VR activity. Once again, you can browse through. If somebody wants to actually use OpenGL on top of this, the framework actually allows him to. So you don't have to use only Razawal framework. And like this, you can easily create a simple VR application. I'm just gonna build it on my phone and show you. That great will do it. So, and I don't know, I think it's pretty simple and straightforward. If any of you has any questions, please let me know. Still building, all right. All right, there you go. So, as you can see, now I've set the VR mode enabled into true, so we have the two stereoscopic images, but if I run it again into false, you're gonna see that the Gradle is still building. Yes, please. Now, I hope it's gonna build it, and you're gonna see that on the VR mode enabled false. We're gonna have only one screen, and we're gonna be able to see it much better without any cardboard. I think this is for me. Please, if you got any questions, this is the time to ask. Yes? Yes, they do support videos. You can either put your videos inside your device, and oh, by the way, sorry, this is the VR mode enabled false. You can see that it's only one picture. Now back to your question. It does support video. Yes, I haven't worked with any YouTube videos, YouTube rendering, but I have made it work with local videos on your device, and if you have the actual video file in your server somewhere, I know that it can do this. I'm pretty sure that it supports YouTube rendering as well, but personally I haven't had the chance to try it out. Yes?
Is it only for Google Cardboard, or Daydream VR can also build this, or what can we do to add the feature to use on Daydream VR?
Right now, I think like a week ago that I went on Razawal GitHub page. They haven't had any announcement for Daydream, but I'm pretty sure that they're gonna implement it, because they actually implemented the VR SDK really quickly. So right now the answer is no, but I believe that in a few maybe weeks or months we're gonna have something. Yes?
Do they have support for Gear VR?
Yes.
Do they have support for Gear VR?
For what? For what?
Gear VR. Samsung's
Oh,
version.
yes, of course. Yes, GRVR I think is for Samsung, so it's still Android, so we're talking about the same thing. The interaction on GRVR I think is with touch on the screen, right?
And there's a touchpad.
Yes, and that goes straight into the screen. So for GRVR we have to implement the on-click listener on your view. So another hand as well. Yes? Well, it depends on the game. If you want to develop something like real heavy, I'd probably tell you to use a game engine like Unity or Unreal. But if it's something fairly simple and it can happen with, you know, only some 3D models, simple animation, simple objects like spheres and cubes, then yes, yeah, you can. Next. All right. So that was from me. Thank you very much.